Hello everybody. Today I can prepare for my coordinate geometry test by practicing. The big bulk of this test is going to be on coordinate geometry proofs, but there are some other things that we need to go over, starting with our partitions, our directed line segments. Anything with coordinate geometry, put it on the grid to make it easier for yourself. I've got M is negative 8, 1. I've got R is 6, 8. Very, very commonly asked question. Not hard whatsoever as long as you know how to do it. Delta X over P, delta Y over P. Key, you're adding together the parts of the ratio, so 3 plus 4 is 7. And delta X and delta Y, we're counting. Delta X, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 1, 2, 3, 4, 5, 6, 7. So delta X is 14, delta Y is 7. 14 over 7 is 2, 7 over 7 is 1. Now I'm going to count 2 in the X direction, 1 in the Y direction. 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, 1, 2, 1, and I should end at the other point. I'm starting at M, so M is 0. This is 1, 2, 3, 4, 5, 6, 7. The answer is the first number in the ratio. If it's a ratio of 3 to 4, I'm looking for 3. The coordinates at that point are negative 2, negative 1, 2, 3, negative 2, positive 4. They're asked on every single region. It's not hard as long as you know how to do it, so practice it as much as you need to until you got it down, get the question right, and move on with your life. This question, not so simple, but is relatively commonly asked. Again, let's get everything on the grid. Getting everything on the grid makes things much easier. 3, 5, 5, 9. It's asking for the perpendicular bisector. Well, perpendicular, negative, reciprocal slopes, and bisector is cut in half at its midpoint. So for perpendicular bisector, I need to find the slope, I need to find the midpoint. Slope equals delta y over delta x. 1, 2, 3, 4, up 4 over 2, positive 4 over 2, m is 2. Midpoint, you can eyeball it. I think that'll be better for most of you. It's right there. Or you can do x1 plus x2 over 2, comma y1 plus y2 over 2. I don't really care how you do it as long as you get it. For some of you, eyeballing it will work, and for some of you, you might prefer to use the midpoint formula. I'm adding the x's and dividing by 2. I'm adding the y's and dividing by 2. I get 4, comma 7. So perpendicular lines have negative reciprocal slopes. So I find the negative reciprocal of my slope to be negative 1/2. My x1, y1 is my midpoint. And now I sub into y minus y1 equals m, x minus x1. Minus means change the sign, so it's y minus 7 equals negative 1/2 x minus 4. Might have to distribute, and I isolate y. But I don't, in this case. Make sure you circle the right choice. Y minus 7, so those are out. Negative 1/2 x minus 4. There's your answer. I would not say this is a simple question. It's definitely a guide to 85 question. It's not impossible, but there's definitely a few steps to it. For perpendicular bisector, for perpendicular, negative reciprocal slope, so I find the slope. For bisector, something is bisected at its midpoint, so I find its midpoint. I do the negative reciprocal of the slope. x1, y1 is your midpoint, and I pop it into point slope formula. Y minus y1 equals m, x minus x1. Find the perimeter of the following shapes. Well, to find the perimeter, I need to add up all the sides. So I have to find the distance of all the sides. So I'm going to start with AB. BC, CD, DE, EF, FA, and that's it. I can count. I got 1, 2, 3, 4, 5, 6, and there are 1, 2, 3, 4, 5, 6 sides. So distance equals radical delta x squared plus delta y squared. You're going to be doing a lot of distance on this test. AB is 1, 2, 3, 1, 2, 3. BC is straight, so I'm not doing distance formula. It's just 1, 2. If it's a straight line, I do not have to do distance formula. I just count. DC is 1, 2, 3, 1, 2, 3. DE, 1, 2, 3, 1, 2, 3. It doesn't matter which direction you count in. EF is 1, 2. Again, I don't need distance formula because it's a straight line. FA is 1, 2, 3, 1, 2, 3. That's radical 9 plus 9. 9 plus 9. Radical 9 plus 9. Radical 9 plus 9. Radical 18. Radical 18. Radical 18. Radical 18. So when I add them all together, I get 4 radical 18 plus 4. Now I have to reduce the radical. I break it down into perfect squares and non-perfect squares. 1, 4, 9, 16, 25, 36, 36, 49, 64, 81, 100. 18, the largest perfect square that goes into 18 is 9. You can use the calculator trick. You can go to y equals 18 divided by x. Go to your table. You're looking in y1 for the largest perfect square. There it is. It's 9. 9 and 2. 4 stays out front. Square root of 9 is 3. Radical 2 plus 4. 12 rad 2 plus 4. If you're like, okay, Mr. Slansky, I get it, but I can't reduce a radical, well, you're going to get 1 point out of 2. And if it's open response and it's asked you to reduce a radical, which I think it will, you're going to have to be able to reduce a radical. Which brings us to the proofs. So I'm not going to sit here and do all the proofs because I've already done that. I'm going to pull up the answer key and just talk our way through it. Actually, time out one moment. First, let's just talk about how to prove all the different shapes. It's all up here, so you should have this. It's in your packet if you want to take a screenshot of it, but everything is here. We're always using distance, except for trapezoid, in which case we're doing slope. So, if I'm proving an isosceles trapezoid, I say that CAMI is an isosceles trapezoid because I go back to that sheet of what I memorized. It has one pair of opposite sides parallel, and it has congruent legs. So for the parallel lines have the same slope. I find the slope. For the congruent legs, I find the distance. And then in step 3, I put it together. So step 1, I said there's one pair of opposite sides parallel. Tell me the sides are parallel because they have the same slope. And if I said that it has congruent legs, tell me the legs are congruent because they have the same distance. So that's how you prove an isosceles trapezoid. For the trapezoid, one pair of opposite sides parallel, so that's slope formula, delta y over delta x. Congruent legs, that's distance, radical delta x squared plus delta y squared, and then we tie it all together. So you will have, I'm telling you exactly what you're going to have to do. You're going to have to prove an isosceles trapezoid. You're going to have to prove an isosceles right triangle. Joy is an isosceles right triangle because it has two congruent sides. So I found that it had two congruent sides using distance, and its sides fit the Pythagorean theorem. So after I found all three sides, I show that it fits into Pythagorean theorem. That's a little bit different than the rest. Everything else is congruent and parallel. The only one that's different is the right triangle, where we show the sides fit into Pythagorean theorem. That allows us to do it with distance. There are other ways to do it, but I find this to be the best. You're going to have to prove that something's a rhombus but not a square. So I say it's a rhombus because, again, what I have memorized from that page I just showed, all sides are congruent. I found all four sides and showed that they were congruent. To prove a square, it needs congruent diagonals. So to prove it's not a square, the diagonals are not congruent. So I found the distance of the diagonals and showed they were different. I said the four sides were congruent because they had the same distance. And then I said that the diagonals were not, that's a little typo there, the diagonals were not congruent because they don't. And that brings us to, I believe, the final proof. We want to start by proving it's a right triangle, so we already talked about that. It's a right triangle because its sides fit into Pythagorean theorem. We find the three distances, we show it fits into Pythagorean theorem. Then it says to state the coordinates of n, the image of P after a rotation of 180 centered at 1, 3. And then it says to prove that Pent is a rectangle. So we talked about this. We don't have to do 180-degree rotation. We just have to find the fourth point that makes it a rectangle. So that's what they always ask. They may ask you to do it in a way where you're doing some type of transformation or something, but let's do it the way that we've always done it. If it's going to be a rectangle, whatever I do to get from P, let me just zoom in on this a little bit here. Whatever I'm going to do to get from P to T, I'm going to do to get from E to N. So I'm going down 1, 2, 3, 4, 5, 6, right 2. So from E, I'm going down 1, 2, 3, 4, 5, 6, right 2, and that gives me N. Make sure you state the coordinates. I had a student get a 64 in the regions because they didn't state the coordinates. And once you have N, it says to prove that it's a rectangle. So I state that it's a rectangle because what I have memorized from that previous sheet I just showed, it has two pairs of opposite sides congruent and diagonals congruent. I already found the three distances up top. I don't have to find them again, so I find the three other distances. Once I have them, I do the same thing I did before. I state what's congruent because they have the same distance. So one more time, what we're going to have to do with the coordinate geometry proofs, you're going to have to prove that it's an isosceles trapezoid. An isosceles trapezoid has one pair of opposite sides parallel and congruent legs. For the opposite sides parallel, that's slope, same slope. For the congruent leg, that's same distance. You're going to have to prove it's an isosceles right triangle. An isosceles right triangle has two congruent sides, and that's for the isosceles, and its sides fit into Pythagorean theorem. That's for the right triangle. You're going to have to prove it's a rhombus but not a square. To prove it's a rhombus, all four sides are congruent and the diagonals are not, to make it not a square. 6 distances. And you're going to have to prove a right triangle again. You're going to have to find the fourth point. Again, I wouldn't do anything about the transformation if you don't know how to do that. Just find the fourth point by counting what you did to one side to the other. And then you have to prove a rectangle, two pairs of opposite sides congruent, and diagonals congruent. Other than that, again, we talked about everything else. You're going to have to do a partitions problem, delta x over p, delta y over p. You're going to have to write an equation of a perpendicular bisector. For perpendicular, negative reciprocal slopes, so find the slope. For midpoint, either eyeball it or do your midpoint formula. Once you have them, you pop them into y minus y, 1 equals m x minus x1. You're going to have to find the perimeter of a shape by finding the distance of all the sides and adding them together and reducing the radical to put into simplest radical form. And then that brings us to the proofs. That's all I got. Practice. Make sure you know how to prove your shapes, or else it's going to be a bad day. See ya.